Hello, welcome back to this SAT class. And in today's class, we'll be talking about absolute values. This is a unique concept in the SAT, and I think it's worth learning. So let's go right into the class. Now, the text we're working with is from SAT Mastery Book One. Okay, let me just go to their homepage and show you what it looks like. So this is SAT Mastery Book One. I think this is one of the best materials I've seen thus far for concerning the SAT. So let's go ahead to solve the question on the topic we have for today, and that's absolute value. Okay, so I'll just do some reading and we'll flow together. You understand? We'll flow together. We're in this together. So let's do this together and we get on with the lesson. Okay, a pair of vertical bars are the symbols for absolute value. So if I have, let's say y like this, and I have a pair of vertical bars, this means the absolute value of y. I can have m, so that's what it simply means. Let's continue. Okay, they are similar to parentheses. I want to talking about parentheses. I'm talking about brackets. Okay, content within the bars must be evaluated first, and all that and all that. So actually, I am going to be instructing, so I will not really go through the notes accordingly. I will skip some things and get ahead into solving questions and all that. So at this point, talk about PEMDAS. PEMDAS in Nigeria, we use what is called board mass. It's actually the same thing with PEMDAS. And let's just get into the class. Now, one thing about absolute values is that you don't have negative. Absolute values are more like distance from point. And whether you are going forward or backward, you can't say you are going negative. It's not possible. So because of that, we don't record negatives in absolute values. So for instance, you see this example here. They said 5 is giving you positive 5, and negative 5 also gives you a positive 5. So for instance, if I have in the absolute value negative 3, it will result to 3. If I also have positive 3, it results to 3. So it doesn't have negative. Don't worry, if this is confusing you, it's not a problem. Let's just get into the class, and when we solve some question, you understand better. So let's just get into this. You can pause this video to read the notes or take down some points if you wish to, but I'm actually more like instructing, so I wouldn't take it bit by bit like you would want to. Okay, so just a moment, let me get this. Okay, we'll have this now. You say, what is the value of 7 plus n minus 5 if n is 3? So let's solve this here. I hope this is not going to be confusing for you. So 7 plus n minus 5. Okay, let's solve this. And if n is equal to 3. Now look at this. We have 7 plus n is 3. So 3 minus 5. What's 3 minus 5? 3 minus 5 is negative 2. So 7 plus, in this we have negative 2. Now pay attention to this. Remember, we say that whatever you have inside this absolute value parenthesis is always going to give you what? Always going to give you a positive. So right here we have negative 2. We cannot have negative. So from here, let me continue from this point. We have 7 plus 2. Okay, don't mind this. This is 7. So 7 plus 2 is what? 7 plus 2 is 9, right? So 9. We are left with 9. So I want you to pay attention to what happened here. And this is where everything is going to be focused on. So let's see what they did and get to know how they were able to fix it. See, they also got 9. So what was the major thing they did? They just affected the absolute value rule here, and that's it. So let's just get right into more examples. Okay, I think we have a more complex example here that says um 5 minus 3 into absolute value of 1 minus 7 into t minus 1 minus 2 absolute value. Okay, it looks quite complex and all that, but t is equal to 3. So let's just fix this. So for this one, 5 minus, since this is a separate parenthesis, you can treat it. 5 minus 3 is what? Is 2. So let's say 2 in brackets. So from here, let's solve for here. Okay, let's fix this inner place first. So we have the absolute value function 1 minus 7 in bracket 3. T is equal to 3. 3 minus, okay, 3 minus absolute value negative 2. And then you have brackets close under absolute value function, and then brackets close again. So what's happening here? So here we have 2. From this point, before we start fixing this, let's fix inside this inner part. So we have absolute value function of 1 minus 7 into, remember this is an absolute value function, into 3 minus, remember, because of the absolute value function we have here, we're expecting to have what? A negative 2. Sorry, a positive 2, because you don't have, don't forget it, you cannot get a negative from an absolute value function. So we have 2. So you see, we are done with that. This closes the absolute value function included. So let's continue. From this point, to have 2 into, so from here, 3 minus 2 is 1, right? Okay, that's 1. So 1 minus 7 in brackets 1, and then you have the absolute value function closed. I don't know if this is confusing to you. I don't know if you followed through, but I think it's not really complex. Just pay attention. And now, remember, if there's any point of this lesson where you're confused or you don't understand, just pause the video and go through it again. Just take it easy. It's simple. I don't think this is complex or confusing. Okay, let's continue. So from this point, we have 2. Okay, and here, so let's just do this. Can multiply this. Minus 1 times 1. Minus 7 times 1 is minus 7. So we have um, 1. Okay, let's have the absolute value function first. Then you have 1, then minus 7. Absolute value function again, and then you close it. So 1 minus 7, let's continue from this point. So you have two brackets. 1 minus 7 is what? Absolute value function. 1 minus 7 is minus 6. Then absolute value function, close it. So we're almost done with this. So from here we'll have 2 is into, what is the absolute value function of negative 6? Remember, we said in absolute value function, you can't have a negative number, so it's just 6. So we have 6. At this point, remember parentheses or brackets, it simply means we have to multiply. So 2 times 6 is what? You're having 12, and that is our final answer. So let's look at the explanation they gave here and see if we are consistent with that, and if we are correct, we can think we are good to go. So let's just go down. Okay, so let's see what they did. Okay, they got 12. Nice. They got 12. I think they did the same thing, and that was nice. Now look at this. Maybe you're confused about how I got the answer. You can go through this video again, or you can just take a look at what they did. Let's go on to the next example. Okay, now I have a question. It says, okay, let's just read this. Algebra with absolute value. So now let's look at the use of absolute values with a basic algebra 1 problem. If you are feeling confident, give the following question a try before you read my explanation. So let's go through this. It says, if A and B are the two solutions to the equation, absolute value function of x minus 4 is equal to 5. What is the value of A plus B? So absolute value equations usually give two possible answers, because one has to be negative and the other has to be positive. But from the absolute value function bar, they're always expecting a positive answer. Now, this might not be clear to you, but let's go ahead and solve this question. So we have the absolute value function of x minus 4 is equal to 5, or absolute value function of x minus 4 is equal to minus 5. So these are the two possible values. I don't know if you get that we can get, and it doesn't change anything. So from here, let's have that x minus 4 is equal to 5, or x minus 4 is equal to minus 5. So I'm taking away the absolute value function bar. So here is x equal to 5 plus 4. I'm collecting like terms or adding 4 to both sides. So this 4 coming over this end becomes 5 plus 4. And that gives me s is equal to what? 9. And from here I have that x is equal to what? Minus 5 plus 4. Be careful about that, because this moving turns to positive. So minus 5 plus 4 is what? X is equal to minus 1, right? So negative 1, and that's what we have. But they said, what is the value of A plus B? So assuming this is A, we can just call it. So therefore A is equal to 9 and B is equal to minus 1. So let's add it up. So 9 plus minus 1, that is same thing as saying 9 minus 1, because minus will supersede the positive. So 9 minus 1 is what? 8. So we have 8. Let's check and see what they have. You actually pause this video and read through. I'm just skimming through or making sure I help you understand what is happening here. So this is it. You see, they distinguished it into two different listings, and I think they did the same thing we did, and they are also getting what? Let's see their final answer. They're also getting 8. Yeah. So look at it, they got 8. Okay, now they tested the value. So x plus x, when x is equal to 9, so they just put it in and it's giving them yes. So this makes sense. It makes sense. And this as well. When x is equal to -1, it makes sense. I don't know if you understand. Let's go back to this and let me just show you this. Maybe this will help you understand better. Now look at this. We had two values, right? When we solved, we said that x could either be 9 or -1. So let's check this out. From here now, let's plug in 9. So let's say 9 minus 4 is equal to what? Is equal to 5. It doesn't change anything. And even if you have the absolute value function, so I can give you 5, it's still equal to 5. Nothing changes. Then let's say when you have -1, so -1 as x in the absolute value function, -4, what is it going to give you? This is giving you -5, right? And you know that from the absolute value function, you can't have a negative. So it's giving you +5 again. So we actually correct. This was just what they explained in this point where they say check. So this is the explanation here. We're talking about check. Let's continue. I think class is progressive. Let's get to solve another question. This question says, if n and t are the two solutions to the equation, what is the value of n plus t? Okay, let's do this together. Let me just get rid of some things and then we can walk through this. So look at the question we have 2, then we have an absolute value function x minus 8, and then plus 4 is equal to 12. Let's simplify this using algebra, so or linear equation. So have 2 into this x minus 8 is equal to 12 minus 4 first. So 12 minus 4 is 8, right? So 2 into x minus 8 equal to 8. So you also have this coefficient. Let's divide through by 2, right? And break it down. So let's divide 2 through by 2. Dividing through by 2, that gives us absolute value function of x minus 8 equal to 4, because we're dividing every value here by what's it called, by 2. Okay, hope this makes sense to you. If you don't really understand, just pause the video and go through it again. Or as well, you can as well just use this 2 to multiply through this bar and it will give you something. But I think is better, is ideal when you work this way, dividing through by 2. So 2 cancel out here and 2 divided by 8 is 4. Let's continue. From here, you now have x minus 8 is equal to 4 positive, or x minus 8 is equal to -4. From this point, let's collect like terms to have x equal to 4 plus 8, and then x is equal to 4 plus 8 is what? 12, right? Okay. Okay, just a moment. So 4 plus 8 is 12, right? 12, and here we'll have x equal to -4 plus 8, because it's crossing over. So here is x is equal to -4 plus 8 is 4. So now they said if n and t are the two possible solutions. So here you can say that n is equal to 12 and t is equal to 4. What is the value of n plus t? 12 plus 4 should be 16, right? So n plus t is equal to 12 plus 4, based on what we solved, is equal to 16. Let's check if we did the right thing or skipped any detail at any point. So we are having, yeah, exactly same thing, 12 and 4. So if you combine, you're going to have 16. Exactly what it did. So that makes sense. Okay, let's talk about graphing absolute value. Okay. Okay, so this is a typical absolute value graph. Okay. Okay, using absolute values in graphs can cause some interesting effects. Now, since absolute values cannot produce negative values, neither can their graphs. So their graphs usually very difficult. Though they can, but it's rare. They have this sharp look, this sharp V look. So I think in this book they also talked about when you flash. I think for me, I would say flashing a light in the mirror and you see that light reflecting back with that kind of force. I don't know if you get it now. So just bounce and come up. So when you see this sharp V, it talks about absolute value graph. So this is a typical absolute value graph, and here is the function of y equal to absolute value of x. So it's quite different from the conventional linear graph. So let's just continue. So you can go through this, read it up if you wish. But let's get into this lesson. So for example, let's consider the graph of the equation. Now look at this graph. Why is this graph like this? Now remember we said absolute value graphs do not take negatives. But why is this graph taking negative? Now I want you to think about that. Now look at this, look at the graph. This is the graph, the y, and then you have the absolute value function here. But something is happening is then after this absolute value function now, whatever you have here is being pushed 3 units downwards. So from what we had, assuming it's just here without this -3, look at this. That okay. So with that -3, without this -3, you see this now, without this -3, what do we have? We are going to have just this, right? So and that should be somewhere around here like we saw in the previous graph. It should be somewhere around here. But what's happening because of this -3 is going 3 units downwards. So you see unit 1, unit 2, and then 3. So it went 3 units downwards because of what we the effect we had we just saw now. Okay, so this is the graph of this expression y equal to absolute value and then -3. So let's continue. Okay, we have another example here. Let's figure it out. Okay, option. Okay, latest question 2. Which of the following equation could define the graph shown below? Okay, now look at this. Before you even try solving this, just eliminate some option. This is more like a linear graph, so we're taking it off. And then this is also more like a linear graph, we're taking it off. They don't make sense right here, so they're out. Now look at this other graph now. In this other graph, in this option C, every of the value is in the absolute value bar. So because they are all in the absolute value bar, we don't expect to have a negative in this graph. So this particular one shouldn't have a negative. But now this graph here is having a negative. So it doesn't make sense. This doesn't just make sense. Now over here, you can see this now. After you had the absolute value function, it was going 2 units down. So this makes sense with what we are talking about right now. So option D is the accurate option. But let's check out what they have and see what they said. So we can look at this. They say choice D. So choice D makes sense. Makes sense. So just follow the explanation I gave you now, and I think you understand this better. Let's go for more examples. And okay, review and encouragement. I think this is sometimes I like to read this review and encouragement. So oftentimes I read this, but I wouldn't take time to read it because I'm more like instructing, so I'm not going through every details. So here it says absolute value is not the most common topic on the SAT math test, but definitely show up from time to time, once every test or so. So the most common mistake I see my students make, according to him, the author, with absolute value question are either careless mistake related to negative signs. So be very careful about the signs. It's very careful. Like it's very important. Be careful about the negative sign. Failing to properly set up for the two equations. So only set up for two equations, two solutions to absolute value. So set up for two solutions and all that. So when it comes to graph involving absolute value, look out for this signature V. We talk about the V shape, right? In the direction of the graph roughly shift from sloping downward to sloping up. As I mentioned, it reminds me of a lesser beam, yeah, reflecting off a mirror. So I've never seen a particularly difficult absolute value question in SAT math. These questions tend to be relatively easy, and when you understand the rules laid out in this lesson, you find them quite simple. So they are usually simple questions, they're never difficult. Let's go ahead and fix these questions on the practice. Okay, so let's do this together. For question number 1, it says if x is less than 0, what is the value of x in the equation? So I think maybe don't pay attention to this first. Let's get to solve this equation. Now, you have an absolute variation function. What do you do? Set it into two solutions. So the first one becomes x minus 6 is equal to 10, or x minus 6 equal to minus 10. So from here you have x is equal to, collecting like terms, moving 6 over here, or adding 6 to both sides, you have that 10 plus 6. 10 plus 6. Let's finish this one. So x is equal, 10 plus 6 is 16. Okay, here you had x is equal to minus 10 plus 6, because this 6 is coming over. So x is equal to minus 10 plus 6 is negative 4, minus 4. So now you've been able to fix this. What's the next step? They said x is what? Less than 0. Pay attention to that, less than 0. So now you had two values for x, and one of the values says what? X is 16, and one of the values says what? X is negative 4. Which of these is less than 0? Is it 16 or negative 4? If you just see this, know that negative 4 is less than 0, and that is why our option is B. So we are going for option B. Let's mark B. Let's go for the next question. Question number 2. Okay, question number 2. It says, what is the set of solutions for n in the equation above? Set of solution for n. So what do you simply do? So we'll say then, let's write the question down first. So absolute value of n equal to 12. So let's collect like terms or subtract 3 from both sides. So n is equal to 12 minus 3, because this 3 is coming over here. So absolute value function of n, 12 minus 3 is 9, right? Okay, 12 minus 3 is 9. From this very point, what else can we do? So we see that n can either be what? Remember, let's set the equation up now. So it means that n can either be what? 9, or n can either be minus 9. I think we're done. We don't have anything to solve again. So remember, we have two possible solutions. But just know that the absolute value function don't give off negative. So these are the possible things. Either we are going forward or going backward. Now let me show you this now. Assuming you have a number line. This is a very nice example. And this is 0. You have 1, 2, 3, 4, 5. And here you have minus 1, minus 2, okay, minus 2, minus 3, minus 4, minus 5. If I go 3 units from the left, what will I have? 1, 2, 3. And this is negative 3. If I go 3 units towards the right, what will I have? 1, 2, 3. And this is 3. So I'm going 3 units, but at this point I had negative. At this point I had what? Positive. So this is why in absolute value function you can have two possible things, but then the absolute value function does not give you anything that is what? Negative. It's more like a distance. You cannot have a negative distance. So let's go back to what we have. Let's continue with our questions. Okay. Question number 3 says it's an absolute value function. So here let's fix this together. Okay. So we have that the absolute value function oh, what's wrong with my pen? Okay, so okay, I think just a little challenge, but that's not a serious problem. Okay, so for question number 3, what is the value of t in the equation above? So let's solve this. We'll have that negative 4 minus 2t is equal to 14, or negative 4 minus 2t is equal to minus 14. So that's two possible values. Then I have negative 2t is equal to 14 plus 4. This. So 14 plus 4, because this is coming over here. So negative 2t is equal to 14 plus 4 is 18, right? So let's divide both sides by negative 2. 18 divided by negative 2. So the negative 2's cancel out and t is what? Minus 9, right? So let's do same here. We have negative 2t collecting like terms is equal to minus 14 plus 4. So from here, um, negative 2t is equal to minus 14 plus 4 is minus 10. Yeah, minus 10. So divide both sides by negative 2. Negative 2. So they'll cancel out and t will stand alone. This is 5 because the negatives here will cancel out and 2. 10 divided by 2 is 5. So it says what is the value of t in the equation above if t is greater than 0? So because they are saying t greater than 0, the right option should be 5. Negative 9 is less than 0 according to number line. So the right option should be 5. So for question number 3, so the right option we are going with is 5. 5. So let's check question number 4. Okay. Okay, for question number 4, we have this expression. So let's say, now remember this is an absolute version. This question looks quite complex, but I think it's the simplest question here, one of the most easy questions, one of the most simple questions. So negative this absolute value bar. So no, cannot expect negative from an absolute value function. So we just have 9. At the end of the day, this will become, let's do this here, negative 2x plus 3 equal to 9, or negative 2x plus 3 equal to minus 9. So we have two answers. Let's solve this. So this becomes negative 2x equal to 9 minus 3. 9 minus 3 is 6, right? Negative 2x equal to 6. Divide both sides by negative 2. 6 divided by negative 2. So this is x is equal to negative 3. Let's fix this one. So negative 2x is equal to negative 9 minus 9 minus 3. And that is negative 2x is equal to minus 12. Right? So from here, we divide both sides by negative 2. So negative 2 equal to negative 12 divided by negative 2. So here is x is equal to the negative to cancel out and then 6. So possible value says what is the solution for the set? What is the solution for this? So what is the solution set for the equation below? Don't mind me. So that's what 6 and negative 3. And which option is that? So we had 6 and negative 3. So that's the C. 6 and negative 3. Let's check the next question. Question number 5. What's the asking? It says A and B are solutions to the equation. What is the value of A plus B? So this is same thing. X minus 4.5 equal to 3.5, or x minus 4.5 equal to minus 3.5. So here it becomes x is equal to 3.5 plus 4.5, and here x is equal to minus 3.5 plus 4.5. So at this point, 3.5 plus 4.5 is 8. Because okay, 3 plus 4 is more like 7. Then half plus half is 1, so that's 8. So here x is equal to 3 point, this becomes more like, this is saying 4.5 minus 3.5. So 5 minus 5 is 0 point, then 4, this is just 1. So add them together because this is our A and this is our B. So add them together, A plus B is equal to, at this point, 8 plus 1, and that's 9. So our option is D. So we are going for D. Let's go to question number 6. Question number 6 says, if n and t are solutions to the equation above, what is the value of n minus t? So let's solve. So we have 4x plus 12 equal to 4, or 4x plus 12 equal to minus 4. From here, so we have 4x is equal to 4 minus 12, or 4x equal to minus 4 minus 12. So here 4x is equal to 4 minus 12 is negative 8. And then let's just finish up this one. So this becomes divide both sides by 4. minus 8 over 4. So x is equal to negative 2. And then here we'll have that 4x is equal to minus 16, negative 16. So dividing both sides, divide both sides by 4, we'll be left with x is equal to negative 16 divided by 4 is negative 4. And what are we solving for? N. So let's call this our n and let's call this our t. N minus t, right? So this becomes negative 2 minus negative 4, and you put it in the absolute value function. So here is already giving us, let me just do it here, negative 2 minus negative 4. So inside the absolute value function, this becomes negative 2 plus 4. Remember, because of these two negative, and then at the end of the day, you're having negative 2 plus 4 is just 2, and that is same thing as 2. So our final value should be 2. For number 6, I'm going with 2. Let's check question number 7. We're almost done. Just stay patient. Hang on. Okay, 7 is very simple. I don't know if you can see just the graph. Okay, it says which of the following equation could produce the graph? So remember, option A is more like a linear this thing. It does not have this absolute value function. So we are taking option A out. We're also taking option D out. So we are left with this now. Now remember this. Everything you have here. Okay, look at this now. This is saying that you have an absolute value function and then it's going all the way down, like 4 units down. But this graph did not go down. So you see, by elimination, I can just choose C. And it makes sense because it just went like 4 units within horizontally. And then the absolute value function encapsulates everything, which means it didn't go negative. So C makes more sense. Let's check. And we are done with that. Let's check question number 8. Question number 8 is a little bit complex, but you can still fix it. It says a number line contains two different points, A and B. The points are both 7 units from the point with coordinates minus 2. So let's draw. So you have coordinates minus 2. So minus 1, 0, 1, 2, 3, 4, 5, 6, 7. This one is minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10, right? This is a sketch. It says that the points has both 7 units. So 7 units from this. 7 units is 1, 2, 3, 4, 5, 6, 7. So 7 units I have 5. Then 7 units here is 1, 2, 3, 4, 5, 6, 7. 7 units I have minus 9. This is minus 9. Because you're having minus 7, minus 8, minus 9, minus 10. So this is minus 10. So these are the values we have. And then we can do it is just put it inside the absolute value function bar and you check it out. So let's say negative 2. So negative 2 plus 7. What is it going to give you? It's going to give you positive 5. And if you as well say negative 2, negative 7 minus 7, it's going to give you what? Here, it's going to give you negative 9, right? So that's going to give you negative 9. It's going to give you negative 9 for this other side. And then you know in absolute value function, if you're having negative 9, just but whatever, look at what I want you to figure out to pay attention because this question is just a tricky one. I want you to pay attention on to what is obtainable. And what do I mean by what's obtainable? What are the possible things we can get when we work with this? Possible things we can get when we work with this is for the first one, this um can transform into positive 5 and this can transform into what? Negative 9 in the absolute value function. That's what we're looking at for. It says the solution to which of the following equation gives the coordinate of both. So let's check now. Let's plug in these values here. So if we have 5 minus 2, will it give you 7? No. Now if we have minus 9 minus 2, will it give you 7? It doesn't make sense. So A is out. A does not make sense. Let's check this now. Put in 5 here. 5 plus 2, will it give you 7? Makes sense, yes. But let's check minus 9 plus 2, will it give you 7? Yes, like look at this, minus 9 plus 2. This is what? Minus 7. But remember, we have an absolute value function to give a positive 7. Makes sense? But before we conclude, let's check another person. So let's check this now. 5 minus 7 is 2, right? 5 minus 7 is negative 2, and if you put it inside the absolute value function to give it 2, makes sense. Let's check. Minus 9 minus 7 is about minus 16. C is out. I'm testing them now, so I'm plugging in these values. Don't know if you get. So if you plug in minus 9 here, minus 9 minus 7 is giving you about, let's do it. So x is now minus 9 minus 7, giving you what? Minus 16. And this positive will give you this, like 16. So C is out. So let's check. 5 minus 7 is minus 2. Oh, absolute value functions do not give negative, so D is out. B makes more sense. And from our work, we see that B was accurate. Let's check question number 9. Okay, we have another absolute value graph. Which of the following equation could produce a graph? Now, this graph is very complex, right? Because it's even inverted, so it's an inverted V. Okay, and the options are quite tricky because you don't have any algebra, so you can't just rule anyone out. So we have A says you have negative of the absolute value function and it's dropping one unit down. It makes more sense. Now, negative because this graph is inverted. I don't know if you get, so it's inverted. But then, what can we do? Just a moment. Okay, just like I was saying, let's consider this now. This is saying that you have a positive absolute value function, but it's going all the way one unit down. But that's not what's happening here. We have an inverted absolute value graph. So this is out. This is saying that you have positive and also one unit down, out. This one is saying that everything is positive, but we have the graph on the negative, out as well. So look at this, focus on this. So you have that this graph went one unit down, you see, below the positive this thing as is, like went one unit to the negative. And then this absolute value function also have a negative here, which means it's inverted. So I think A makes more sense. So let's check for the last question. Okay. Wow, 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 wow. Made it to the end. So just a moment, let's get rid of this and solve this last question. Okay, question number 10 says we have this, we're going to work with this, we're going to work with this. So G and H are points on the number line that are 12.5 units from the point with coordinates minus 6. So 12.5 units from coordinates minus 6. So we're going to do three things like 12.5. So minus 6 plus 12.5, or minus 6 minus 12.5. Okay, let's just finish the question first from the point with coordinate minus 6. And the coordinates of point G is S. So S is actually G. And the coordinate of point H is T. So this is T. Then what is the value of the expression above, and what is the expression S plus S minus T? So from here, this will give us 6.5, 6.5, and from here this will give us minus 18.5, right? Okay, so this is what we have, and they are saying x minus 2. So let's check. S is what? 6.5. So 6.5 um minus, what's this? Minus 18.5. Let's put everything in the absolute value function. So what I'm doing now is I'm solving for S minus T. So this is S, this is my minus, and this is T. So from this very point, you can now see that 6.5 plus 18.5, add it up. So okay, 18 plus 6 is what? That's 24. Then 0.5 is 1, that's 5, right? So we have 25. So this will give us 25. and the final answer is 25. I hope this makes sense to you. Now let's look at the let's look at what you have here, and then let's take number 1 to 5, and then we take 6 to 10. So number one is BD5CD. So let's check BD5CD. See what we did. Just a moment. Question number 5. So we had what? Number one we said B. So B, right? So we got number one. Number two, we said number two. Did we even choose an option? We should. Number two. There's our answer. Okay, we said 9 and minus 9. I didn't even mark it. So BD. So that's it. D. Number three, 5. So let's check if we got number three. Number three, 5. Look at it. We have 5 here. So number three, we got it. BD5. What's the third one? I've forgotten. Okay, what's the fourth and fifth? I forgot the fourth and fifth. Oh, so quick. Let's check it again. So CD. Okay, 4 and 5 is CD. Let's check 4. 4 and 5. 4 is C, right? So got it. C, and then 5 is D. Let's check. Okay, got number 5 as D. Got it. So let's check from 6 to 10, and just a moment we are done. Just trying to review. 6 to 10 says 2CB825, 2CB825, 2CB825. So number 6, what did we get? Number 6, we got 2. Yeah, we got 2. So 2C, we got C. Yeah, number 7 is C. Number 8, B, right? Let's check number 8, 9, 10 again. BA25. So let's check. B, 8 is B, 9 is A. Okay, correct. And finally, you're left with 25. Now, if you had any point in this lesson where you are confused and you didn't get it, pause the video, go through it again. Now you can make a time for yourself, take some notes, go through the lesson again. Now, you can go through some of the key points that the author of this book mentioned and some of the salient points I made. Okay. Now, if you want to see how the author did the calculation himself, so this is it. You can pause this video and go through it if you want to see that for yourself. But I'm telling you, I just love this mastery book. The author is amazing. He's phenomenal. Like, he's just good. Like, this is me seeing someone using English language to explain math codes, and it's just beautiful. So you can pause this lesson and go through it. So these are the solutions he gave. Just nice. Having said that, this class is done. This class is powered by Precision Academic World. Now do well to join us next time on this same channel. My name is Mr. Johnson and I'm your instructor. And you know what? We are working with SAT Math Mastery. This is for the one, the second edition. So this is Love the SAT Test Prep present. So this is from this company by Christian Health, founder of Love the SAT Test. So I think this company is amazing. Like, they are good. Thank you so much and join us next time. Bye.